Hello. Okay. Since you guys seem to like my videos, which is good, I decided, well, this might be a good thing that I record since I'm gonna be gone, especially those that were absent. This week. If you guys come into class next week, you might be completely lost. So it's okay. But this video is to help catch you up. Okay. So this first part is on trigonometric ratios, part 1. Okay. So if you ask your friends in class, I did show a video how this works. But basically, trigonometric ratios, you can use the acronym SOHCAHTOA as an easy way to help you remember how sine, cosine, and tangent are related to a right triangle. Okay, so one of the things that I went over in class, so trig ratios, these sine, cosine, and tangent ratios, they can only be applied to right triangles. Okay, so this spells so, this spells ka, this spells toa. Okay, so the opposite side refers to the side that is opposite of this angle, and the hypotenuse is the longest side of the right triangle. The adjacent side is the side that is next to this angle, and you want to refer to the hypotenuse of the right triangle in order to find the cosine. For the tangent, so this is the first part that we're going to go over. So tangent is equal to the side that is opposite of this angle divided by the adjacent side, so the side that is next to this angle. Okay, and this point of reference will depending on which angle you're referring to. Okay. First, before we begin, I want to show you the trig table. So some of you saw the trig table in class. I know some of you, if you were absent, this might look like a complete mess to you. But I'll just show you how you would use it. So the way I showed it in class was, for example, if you want to find the tangent of 10, so this is the tangent, this is the 10 degrees. So if you want to find the tangent of 10, if you look, you just look at where these intersect. So that means the tangent of 10 degrees is going to be 0.1763. Okay, if you want to prove that, you can use a calculator. Okay, so with this calculator, make sure you're in mode. I still don't know why these graphing calculators do this, but make sure you press mode. Make sure you are in degrees. They seem to reset for some reason to radians. So I'm going to make sure before you guys take your Module 13 test, which is probably going to be in late April, make sure you change your calculator to degrees. Otherwise, your answer is going to get all kinds of messed up. Okay, so make sure your calculator is in degrees. Okay. Anyway, so the tangent of 10 we said is 0.1763. So if I type in tangent of 10, it should be 0.1763. Okay. For example, let's say I want to find the tangent of 19 instead. So if I look at the 19, that means the tangent of 19 on this table is going to be 0.3443. So we can prove that by just putting tangent of 19, and that will give you 0.3443. Okay. Let's say I wanted to look at this instead. So if in this one here, so the tangent of like 50. Tangent of 50 is going to be 1.1918. So if I type that in, tangent of 50, 1.191. This is rounded. This is rounded to 1.1918. Okay, so this is how you would use these trigonometric ratios. You could use a table if you're too lazy to put in your calculator, or you could just use the calculator if you want a more exact answer. Okay, right. So let's try to work out some examples. Okay. So the first example that I gave, this is on the tangent ratio. So this is section 13.1. Okay, so for this one, let's say we wanted to find the tangent of each angle that is given. Okay, so if I had to draw a triangle, let's say this is my triangle. This is going to be, I'm going to label this triangle ABC as a right triangle, and it has sides. One side is 5, one side is 12, and the other side is 13. Okay, so let's say we wanted to find the tangent of C. Okay, so if we want to find the tangent of C, what you would do is you look at the side that is opposite of C, angle C. So one way I've been teaching some of you in class is imagine that you're a person. You are a person looking in this direction. You are looking in this direction. If you do look in this direction, you want to look at the side that is opposite of you. So the side that lays directly opposite of you would be this side here. So the tangent of C in this case, so if you guys remember the acronym is SO, CA, TOA. Right? So refers to the sine ratio. The cosine represents, the CA represents the cosine ratio, and the TOA represents the tangent ratio. Okay, so the tangent of C is going to be equal to the side that is opposite. So the side that is opposite of angle C is going to be 5. And we look for the side that is adjacent or next to angle C. That is not the hypotenuse. If you're using the hypotenuse will only be applied to sine or cosine. Okay, so from here we look at the side that is adjacent or next to angle C. What we see is that would be this side here, CB. So that means the tangent of C is going to be 5 divided by 12. Now, if we put an angle here, let's say we put a random angle here, and most of our problems will deal with angles. Well, this is a Greek letter. This is called theta. Okay, so theta, one way to also think about this is also equal to the tangent of theta. So actually wait, hold on, let me erase this. First, before I do that, I'm going to reduce this fraction. Okay, so 5 divided by 12 is going to be 0.4166, about maybe I'll just do 0.4167 to round. Okay, so this decimal is going to equal tangent of theta. Okay, so from here, this is what this means is that if you had to go back into your trigonometric ratios, if you had to look for tangent, you try to look at a relationship between these numbers. What you could actually do is you could go back, look at where 0.4167 is. So 0.4167 will be somewhere between 22 and 23 degrees. So if you had to work backwards, that means this angle here is going to be 23 degrees. This is something that we will cover later. It's not going to be the focus of this. I want you guys to understand how you find your tangent ratios, sine ratios, and cosine ratios first before I teach you how to find the angles. Okay? But anyway, that's what this decimal means. And if you went 5 divided by 12, that's how you get that decimal. Okay? The next part. Okay. What if we wanted to find the tangent of A? So let's say we want to find the tangent of this angle. So if you think about it, if you had to look at it this way, you're looking at the side that is opposite. So the side now that is opposite of angle A will be this length here. So the tangent of A will be 12 divided by the side that is adjacent or next to angle A. So the side that is adjacent or next to angle A would be this length here. The tangent of angle A is going to be 5. Okay. I'm going to show you one more problem, and I'm going to stop the video, and then I'll continue on part 2. Okay. So another example that I showed in class was this one here. So we have triangle D, E, F. So this is 6, 8, and 10. So our goal, let's say if we want to find the tangent of each angle, let's say we want to find the tangent of F. So the tangent of F is going to be